Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and continue on the chapter 4 of Oracle's online documentation of Java native interface. So we looked at the different functions to work with strings, and we said that the main problem is that strings in Java are UTF-16, strings in C++ are UTF-8, right? So going from const jchar pointer to const char pointer, it's a little bit painful, especially that none of the functions in C++ or C work with const jchar pointers. So they work with const char pointers, right? So the next function is get a string regen. So if you just want to get a substring, a few characters from a string, you can use regen. This is very similar to arrays. For arrays, get a string, get a double array regen, for example. We give it an index, the start index, and the length or the number of elements, and that takes JVM takes a empty buffer and copies those number of elements from an array into a C buffer, C++ buffer or array. Same here, get a string regen, right? It returns void, so it doesn't return anything. However, it takes a array. So J string, this is our string, which is a character array, J size, a start, right? So the index of the start, the number of elements, which is length, and then jchar pointer buffer. So this is a jchar pointer. This is an array of jchar. This is an empty buffer. We provide it. We provide a pointer to the Java string, and then we tell it from this index and then up to this number of elements, copy them into the buffer. So this is an explicit buffer, explicit copying that we ask JVM to do for us. And again, the problem is that it gives us a jchar pointer, which we cannot really do anything with it in C++. It's always best to ask JVM to give us a string UTF-char, so a const char pointer, an array of char pointers, because then we can immediately use it with any of the CS string, any of the functions in the CS string header, right? So copies len number of Unicode characters beginning at offset start to the given buffer buff, right? Remember, this is a jchar pointer. This is not char pointer, right? This is not an array of chars. This is an array of jchar. And jchar is unsigned short, so it's a two byte unsigned, right? And it throws a string index out of bound exception. I mean, this is an exception that we normally don't see in Java, but yeah, it can actually throw this exception if the start plus length goes beyond the size of the string. Index 220 since JDK 1.2. Get a string UTF regen. Okay, this is good. We should use UTF because then we give it a buffer of type char pointer. So it gives us an array, copies the substring into an array of characters, and we can immediately pass it to stdc out or whatever we want to do with it, right? So UTF is better or best because otherwise we end up with, when we say UTF here in this function, it's UTF-8 or modified UTF-8, which is null terminated. And when it doesn't have UTF, it means it returns UTF-16 or 2 byte characters, and UTF-16 is jchar, right? Jchar is 2 byte. So translates len number of Unicode characters beginning at offset start into modified UTF-8 encoding and place the result in a given buffer. Throws a string index out of bounds exception. Linkage 221 since JDK 1.2. Get a string critical and release a string critical. These are also, we had a in-depth discussion about critical versus regular access to both the primitive arrays and strings, and we said that the problem with a string is that even if we do a critical access, right, the problem is that it doesn't give us a char pointer, it gives us a jchar pointer, although this is a direct pointer to the string on the native on the Java heap, because Java uses 2 bytes, right, by default. It gives us a jchar pointer, and again, the problem then is that we cannot really pass these to stdc out or any function, C++ function or C function that uses a string literals, right? And that's painful. Then we have to manually convert it into char array. Instead of jchar array, we convert it to char array. But at least we know that no copying happens when we use a critical. We know that JVM gives us a raw pointer of type const jchar pointer, right? And because it's a raw pointer, it means that there is another function that starts with release, and we have to call it when we are done with this raw pointer, right? Release a string critical, right? So j string a string, j boolean is copy, and we saw that is when we tested this, we saw that for the critical access is copy comes back false, which means this is not a copy. JVM didn't make a copy behind the scenes. It's just a direct pointer to the 2-byte character array, a basic character array that each character is encoded with 2 bytes, right? jchar. Jchar is unsigned short. Let me bring up the primitive types one more time when we discuss them. Basically jchar is 16-bit unsigned, right? So jchar is unsigned short. Where did we discuss with yes, so jchar is unsigned short when we talked about working with a string. So it's 2 byte because Java stores characters as 2 bytes by default, and we saw that if it's a weird Unicode character, sometimes it requires 3 bytes or more than that, maybe 6 bytes. So it's those, but English characters, Java just encode them in 2 bytes. C++ encodes them in 1 byte, basically ASCII, and ASCII is 7 bits, which is compatible with UTF-8, right? So if we give it a string and j boolean, and also it also has a release a string critical, right? So j string and const jchar pointer c array. And the only thing that happens when we call this release a string critical is that because no copy was made, so the only thing that JVM does it unpins the underlying pointer, right? Unpins the underlying string in the Java heap so that the garbage collector can move it around if there is a need for that, right? So the semantics of these two functions are similar to the existing get release string chars functions. Remember, when we call get release string chars, it gives us a raw pointer, but that's the is copy comes back true, which means it's not a direct pointer. JVM actually made a copy and gave us a raw pointer to the copy. If possible, the VM returns a pointer to a string elements, otherwise a copy is made. However, there are significant restrictions on how these functions can be used. In a code segment enclosed by get release string critical calls, the native code must not issue arbitrary jni calls or cause the current thread to block. And this is the same thing, the same idea with critical. We said that JVM doesn't like to give up control on the Java objects, but if we ask it to give us critical access and give up control, we have to eventually make some promises, right? We need to make some promises to JVM, and the promise that we have to make, the main one, is that in between get a string critical and release a string critical, we're not going to call any other jni function. That's very important, and I want you to really understand it, right? And the problem again with critical access to strings is that the raw pointer is not a CS style pointer. It's not a char pointer. It's a jchar pointer, which is very bad because we cannot immediately use it with any C++ function that accepts a CS style string, right? So in between get and release a string critical calls, we should not use any jni function, any other jni function, right? And when we use critical access, JVM will temporarily disable garbage collection on the string, right? JVM pins it down in the memory and garbage collector is not allowed to move it. But then we should not call any arbitrary jni functions after that, from the get a string critical to release a string critical. The restriction on get release a string critical are similar to those get release primitive array critical. And that's the previous slide here. Again, in between the get primitive array critical to release primitive array critical, we're not going to call any other jni function. Linkage index 224 for the release string is 225, and then array operations. So let's go to arrays, working with primitive arrays and then object arrays. Get array length. That's the first thing that we need to do. We need to get the length of an array. We pass in a j array reference, and we know that the other types like j double array, j int array, they are in C++, they are subtypes of j array. In C, j double array and other primitive arrays, they are just type defs of j array, right? So here, if the J array is the super type, we can pass also a J double array, J boolean array, J int array, whatever. And this returns a J size. And again, J size is just a type def of J int, right? A signed integer. It's not a size T type. It's in modern C++, for whenever we use length, anything that relates to the size of a container or size of an array, we use size underscore T, which is a default 64-bit unsigned integer, right, for all these sizes. But when jni was written, size T wasn't around, so they just used jint, right? So J size is just a syntactic sugar for, or a type def of jint, and jint on 64-bit platforms is just int, right? 32-bit unsigned integer, 32-bit signed integer. Returns the number of elements in the array. And remember that in Java, a primitive array cannot have more than the size of an integer, which is plus 2 billion elements, right? So we cannot have a primitive array that accepts a long. The size cannot be 64-bit. It should be 32-bit. That's one of the restrictions on the Java arrays, primitive arrays. Array, a Java array object, right, returns the length of the array, and then new object array. So primitive arrays are easy. We get the length, and then we say new double array, new float array, whatever type it is. And then if we want to explicitly copy and populate it, we say that set double array region. Region means we can populate the entire array or a sub array, a sub length of it. We give it the index, a start index, the number of elements, and then a C++ buffer that we have. And JVM just copies the elements in the C array into our primitive array, J array, which could be a J double array, J boolean array, whatever. With objects, new object array, we give it the length, right? J size length, and then, however, we need to specify other things. An object, first of all, if primitive arrays, we know that primitives in Java are automatically initialized by the JVM. Object arrays hold objects, and objects are references, right, pointers, which are initialized to null. However, when we call this new object array, we can pass an initial element, a J object, a pointer to an object in Java heap, and then the JVM automatically initializes all the elements in that array with this particular object, right? So we can define or create and initialize an object array immediately with a particular object. But then we have to tell JVM which object we want to put, what's the type of that object, what's the class. And in order to give JVM information so that JVM knows which class, which type of object we're talking about, we always use a JClass reference. I guess by now I've repeated this many times. Or we always, whenever we want to JVM to understand which class or which object type we're talking about, we give it a JClass reference, JClass pointer. So for object array, we have to give JVM the size, the type of object, which is JClass, and if we want to initialize it, we give it a JObject. Now, obviously, we can pass null. Remember, JObject is a pointer type, so we can pass null, null, macro, or we in modern C++, we pass null pointer keyword, right? Constructs a new array holding object. Oh, by the way, we can also pass a 0 because the null macro in C is equivalent to 0, just number 0. Constructs a new array holding objects in class element class. All elements are initially set to initial element, right? Length, array size, element class is a J class, initial element is a J object. Returns a Java array object, or null if array cannot be constructed, which means we run out of memory, for example. So it throws out of memory error if the system runs out of memory. And we said that for object arrays, we cannot get the entire region immediately, or we cannot get a direct pointer to it. We have to iterate through it element by element. So we say set object array element or get object array element, right? And remember, 2D arrays or 3D arrays or whatever arrays, higher dimensional arrays in Java are just one array or arrays of other objects, right? So a 2D array is an array of 1D arrays, and 1D array is an object, right? So a 2D array eventually is a array of objects, and each object is a 1D array. So get object array element, we give it the j object array and then the size, base j size, which is the index. So either get or set object array element, we have to give it a array and then the element. If we want to get it, we give it the index. If we want to set it, in addition to index, we also give it a j object that we want to put at this index of the array. Returns an element of an object array. It returns a j object. Linkage 173, so it takes a j object array and then the index, right? And it can return a Java array, and it throws array index out of bound exception if index does not specify a valid index in the array. Set object array element, we give it a j object array, the index, and also the j object that we want to put at this index inside this j object array, and returns void, right? Set an element of an object array. Linkage 174 takes a j array, j size or j int, which is index, and then a j object. Throws array index out of bound exception if index does not specify a valid index in the array. Array store exception if the class of value is not a subclass of the element class. Remember, covariance applies to primitive object arrays, right? Not like array list or any list type. However, if a class is a subclass, if A, for example, if a subclass of B, an array of A object is a subclass of array of B, right? So this is covariance. However, a list of A, for example, is not a subclass of list of B. That's because of the type erasure. Object arrays or primitive arrays, they don't have type erasure. That's why we can subclass them, subclass the entire array, and the types are remained. However, for lists or any containers, any collection in Java, we have type erasure, so the type is removed. All right, primitive arrays. Primitive arrays, again, we can still get the array length, array length, that's fine. It works both for object arrays and primitive arrays. And then if we want to create a primitive array, we say new double array, right? So for object arrays, we say new object array. For primitive arrays, we say new whatever the type is array, and we give it the integer for length, right? And then it returns a j double array type or a j type array, so j boolean array, j int array, whatever, and that's a pointer to the array in the Java heap. And then we can populate it, so either with the direct copying using the Regen functions, or we can get, after we create it, we get a critical access to it. We get a, for example, for a double array, we get a j double pointer using the critical access to the array, right? So we can both construct the array in C++, and then immediately we ask JVM to give us critical access to it. So new primitive type array routines, array type new, it starts with new, and then whatever the type is, primitive type and array. So new double array, new int array, etc. A family of operations used to construct a new primitive array object. The following table describes the specific primitive array constructors. You should replace new primitive type array with one of the actual primitive array constructor routine names from this table, and replace array type with the corresponding array type for that routine. New primitive type array family of array constructors. New boolean array, it returns a j boolean array pointer. New byte array, it returns a j byte array. New char array, it returns a j char array, all the way to new double array, it returns a j double array. And in C++, these types, j boolean array, j byte, etc., all the way j double array, these are subclasses or subtypes of j object or j array. I think they are subtypes of j array. In C, these are just type defs of j array. These are aliases. In C++, there is an actual hierarchy, inheritance hierarchy, but in C there is no such thing as class, so they are just type defs. New primitive array family of array, so these are the indices: new boolean array 175, byte array 176, and all the way to new double array 182. And all these new, they just take an integer, j int or j size, these are equivalent, of length. So we give it the length. Remember that arrays in Java, the index is specified by integer type, 32-bit, not long, which is 64-bit. In C++, we have size t, which on modern platforms, on 64-bit platforms, is actually 64-bit. Returns a Java array or null if the array cannot be constructed. For example, we run out of memory. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.